Okay, guys, so first off, sorry for the lateness of getting this in. I had some exams proctor today. I had some tests to make. I had classes to teach. Sorry, I apologize. Hopefully you guys will be able to study this while I drive in tomorrow before your exam. All right, so you can see that question one I have written out there still. You can pause the video if you need to write that down for whatever reason. I have two methods to show you for the factoring. The first one is the method where I remove the negative. So this is the one that we did in class where we changed the signs. And then okay. And then we did factor by grouping. Okay, so that is one option. And it's valid. All right, the other option is we leave the negative in. So we would essentially have -2 times 21 gives us technically -42. I'm not going to worry about the signs for everything, just for the two that work. And you'll see the signs actually change the sign. So then we'll still have -2x squared plus 6x plus minus 7x plus 21. We'll factor by grouping again. This time we have to pull out a -2x and then a -7. If you FOIL and then distribute the negative for the first one, you'll see that you'll get both of those back to the original problem. So there's that for you. All right, move on. Okay, remember I suggest that you factor as much as you can. So the top here is a difference of two squares. So x and x plus 8 and -8. And then we need factors of 28. Oops. Factors of 28, that'll give us a difference of 3. So in this case, we need a +7 and a -4. Now, what you can see here is that the binomials don't cancel, but that's fine. You just need to find the numbers that are not in the domain. So you're still going to put them equal to 0. You just don't have to finish out with the full domain statement. Okay. If you want to surprise me, then you would say domain is x such that x is all real numbers except x cannot be -7 or x cannot be 4. Okay, optional for this one. Okay, so that is that. It is required for this one. So x plus 8. Okay, so required for number 4. All right, moving on. So for question 5, you want to factor top and bottom. 27 factors of 27, that will give us positive 6. So we want a positive 9 and a minus 6. And then we need factors of 81, which if you really wanted to write them out, you could. If you can't see, they will actually be 9 and 9, and they're both positive. So the reason why we don't write y plus 9 quantity squared is because they're going to factor right here or cancel out right there. So you end up with y minus 3 and y plus 9. Alrighty. Okay. This problem, you're just going to factor in each spot. Okay, so if you can do your factoring, you should be perfectly fine with problem 5 and problem 6. So again, we have factors of 9. We want to add them to get to 6. So plus and plus. The other factors here would be 1 and 9. And then we're going to do 28. Okay, and the last one's just a GCF. So we'll start here first. Okay, so all the pieces that cancel. X plus 3, X plus 3, X plus 3, X plus 3, X plus 4, X plus 4. So your answer is X plus 7 over. Well, apparently I made everything X's. So we'll just leave it with X's. If that happens to you, just try to write something like subbed Z equal to X. And if you need to, at the end, you can always do Z plus 7 over Z. Okay, I know at least one student asked what happens if we do that. Oh, there you go, that's what happens. And if you really, really want to be shocking to me, you can say something like domain X or Z, whichever one you pick, is all real numbers we'll make it a Z. Excellent. Great job. Keep it up. All right. This one's really nice. You don't even have to do anything but do the flipping and the multiplying by the reciprocal. You don't even need to factor because it was done for you. So already in a factored form. Okay. So you rewrite the first one, then you want to multiply and then flip. And now we get rid of what's common. Okay. Again, you could say okay. All right. Okay, so the next one, I need you to pay attention. The LCD is the same. So you're just going to rewrite it, bring it together, factor, okay. Technically, the domain there would be like all real numbers, but it's fine. Don't need to have it. Again, LCD is the same. Everyone should get number 9 right across the board. Okay. We have a GCF on top of 2. So we're going to pull it out. Okay. There. All right, now number 11, we can do a couple of different ways. So I'm going to show you repeatedly how I did it in class, and then I'm going to show you how to do it with just a common denominator if you can't see it. So the first thing you want to do is list the denominators in factored form. So that's going to be 16x is equal to 4 times 4 times x. So it's not the most factored form, but it's low enough that we can work with it. It's basically in common factored form. So you want to take one of the 4s that are the same, one of the x's that are the same. You also need to include the solo 4, the solo 7, and the solo x. So your LCD is really 4 times 4 times 7 times x, and that equals 112x squared. But I think writing the factors out will be better for you. Okay, that's the option that I recommend because it's actually using the LCD. Now, if you have a hard time seeing that, you can use a common LCD, and I'm going to show you that. But I want to warn you that it is a little bit longer. So here's the next method. If we use just a common denominator of 16 times 28x squared. Okay, then you want to come down and go, okay, 3 16x minus 5 28x squared, and we're going to multiply it by the LCD, which will be 16 times 28x squared. Cancel out what's there. And then what you have left is 3 times 28x. And then in a minute, I'm going to write that a little bit differently. Okay, so I'm going to write these in their more, I'm air quoting, factored forms. So you're going to have 3 times 4 times 7 times x minus 5 times 4 times 4 over 4 times 4 times 7, 3 4s times x. And then here, notice we have a common 4. So I can get rid of all those. So that leaves me with 3 times 7x minus 5 times 4 over 4 times 4 times 7 times x. And that reduces or simplifies to 21x minus 20 over 112x squared. We are back to where we got before, but the LCD was not used. We used a common denominator instead. But some of you said you were having a hard time seeing the LCD. So instead I can show you this way. You guys study it up, decide which method you like better. All right, we have to use method 1 for this case. Remember, that's the one where you make sure they're in single fraction top And bottom, in this case, yes. Then multiply by reciprocal. So if you need an intermediary step here, this is y over 3 divided by 2y minus 9. Follow this rule. Y divided by 3 is times y minus 9 divided by 2. So y minus 9 times y over 3 times 2. Okay. Finito. All right, questions on that? Watch the videos again. All right, method 2 is going to use complete LCD, which in this case is 4 times 7 times x, which is equal to 28x. Okay. You can squeeze them in here however you like. This one gets the whole thing, 28x. This one gets 4 times 7 times x. This one gets 4 times 7 times x. 4 times 7 times x. X cancels, 7 cancels, 4 cancels. End up with 21 times 28x plus 12 times 28. Okay, so let's clean this up a little bit. All I did was move the GCFs to the front. And then I want you guys to realize that 21 and 12 share a factor of 3. You have to do this step on your test or you will not get the full answer. Okay. All right. The next thing we're going to do is a problem using both. Okay, so remember the step you want for the first method is to multiply by reciprocal. And for step 2 or method 2, it's going to be use full fraction LCD. Okay, and we'll discuss that. So the first thing you have to do is get them into one complete fraction. So in this case, we multiply everything by PY. And that's just to get into one fraction. P's cancel, y's cancel, p's cancel, y's cancel. So you get 5y plus 7p over py over 9y minus 3. That y looked like a messed up yp. Okay. Over py. So 5y plus 7p over py. Multiply by the reciprocal. Pull out a GCF of 3. There you go. All right, other side. Same problem. But we have an LCD of PY. Okay. Hold on. I want to take the part that we already worked, and that's where I want to start. Now let's use the LCD of both. Okay, they match, so you know you did the problem right. And honestly, as long as you have the statements and the work, I'll be happy. Okay, so before you can do this one, you want to rewrite it with everybody having a 1 underneath so you can see what's going on and where you're going to put things. Okay, so then you go from here to 1 m to the 4th. It's 1 over z to the 4th. It's 1 over m minus 1 over z. You get the LCD for the entire fraction, and that's going to be m to the 4th z to the 4th multiplied all over here. and then figure out what cancels. This m makes this a 3. This z makes this a 3. So we end up with z to the fourth plus m to the fourth. Those two kind of flip spaces. And then m cubed z to the fourth minus m to the fourth z cubed. And if you really want some brownie points, you can pull out a GCF of m cubed z cubed, which leaves you with z minus m. Okay, that is the most correct answer, but I will give it to you for some of the other answers as well. Or, for the one in front. So this one is also an option. All right, without actually solving, list all possible numbers that should be rejected. So you're going to reject the following list. Mine has 4, yours will have 3. Make sure you factor correctly. Okay. All right. Now this one we actually have to solve. So you need to know that your LCD is x minus 2, x plus 2. And you need to know that in your domain, so in other words, what you have to reject will be okay. So okay. So we can cancel these two out. Combine these two. Subtract 56. Subtract 28x. End up with x squared plus 2x minus 120 equal to 0. You can list out all the factors, but you end up needing x plus 12 and x minus 10, which will give you a solution set of -12, 10. And we keep both of those because neither one is -2 or 2, though in all reality, you should check. All right. All right. Okay, so for 18, I did it correctly. 19, I did it a different way. It still worked, but I'm going to show you the correct way on the video as well. So either way you remember it is fine, but I will show you the way with the true LCD approach. All right, so that's that one. Okay, so the better approach for this one and I have to thank Marcia from my last section who helped me realize this. Even though I wasn't ready to do it on Monday, I've got you now. So the LCD for this one is going to be all of them. So then we're going to multiply them all. Let's move this down just a little bit. Okay, we're going to get rid of the ones that match. And then we're going to end up having BC plus AC equals AB. You end up seeing that we have a GCF equal to C on this side. So then we pull out the GCF. And then we're gonna divide it by both sides by the binomial. So we get C equal to AB over B plus A. Remember, the order doesn't really matter there, but that is the more correct approach and the more correct method. Either way, you got the same answer. So if you do just the combining on the left and then know how to finish it that way, that's fine. If you want to do the one that I just did, that is also fine. And in fact, it is more correct. All right, so this one is dealing with rates. Remember, we have 6 patients in 3 hours. We want to know how many patients or how many hours for 48 patients. We're just going to cross multiply. Get 6x equal to 48 times 3. Divide both sides by 6. That ends up being 24. You need to have a statement. Okay. This question is multiple choice on your test. I still want this. Okay. All right. Nearly done. So for this one, we have varies directly. So we would use y equals kx to the n. We're going to do s equals kt squared. 225 equal to k 5 squared. 5 squared is 25. Okay, that's part of it. Once you have that, you then have to put it back in. Okay. Next one is varies inversely. So we would be dealing with y equals k over x to the n. Here our y's actually swap with our x's. Oops, looked at the wrong problem. Sorry, guys. 216. Then they give you a 2. Done. Okay. All right. All right, so these ones are extremely similar. Remember, volume is equal to side cubed. So we have varies directly. So y equals kx. It's the same as w equals kv or w equals k s cubed, whichever way you'd like to do it. So then we're given this with this. So 1536 equals k times 8 cubed. So divide by 8 cubed. 8 cubed is 512. So k is equal to 3. That looked like a funky t. All right, so k is equal to 3. And then what we do is we say, okay, what is the weight when k is 3 and our side is 4? 4 cubed is 64, so W equals 192 grams. You have to have grams. All right, last problem for the review. We have inversely, so y equals k over x. We are given I for current over k over r for resistance. We are given 14 for the current and 800 for the resistance. So 14 equals k over 800. Multiply both sides by 800. We end up with k equal to 11200. We then want to find the current when we know that the resistance is 1250. Amps. Okay. All right, I recommend you guys watch this as many times as you need to. If you need help with the factoring, I would rewatch some of chapter 5's video. Hopefully you've already done that, and I will see everyone tomorrow for your exam. Remember, it's in class. Good luck.